The thing you're seeing behind on the screen is something that wasn't working in SharkFest Asia, so I'm putting it up here just to please Megumi-san, who couldn't see it. Those are all your phones transmitting. This is basically every Bluetooth device within the range of this little sniffer device here. And it's receiving every information. In most of the time, it's just advertising information. I'm here, I'm here, I'm here, I'm here. So if one of you guys is very clever and turned off Bluetooth advertising, he will still find his MAC address here, because most of the time, if you turn off Bluetooth, it still advertises in the background. It just doesn't recognize, gets recognized by the other devices again. From time to time, you see some Apple devices going through. You see some Bose headphones going through. And the fun thing about Bluetooth, by the way, is the fact that none of that is encrypted. Bluetooth, by definition, is a protocol without any encryption layer. The reason for it was that at the beginning, Bluetooth was designed to be a human interface device, kind of connection system, mouse, keyboard, and whatsoever. And why do we need encryption for that? So starting to use Bluetooth headsets and stuff like that is actually something that was not originally intended. And so Bluetooth, up until the current version, Bluetooth LE, doesn't have any encryption known whatsoever. The current one, Bluetooth 5, starts to have the encryption, but it's TLS 1.1 and 1.2. And everybody knows how secure TLS 1.2 is. Not that secure. So the thing why I can show you this, and this is actually the new thing, is the kind of cool thing. I can show it to you because I have a small little USB device attached to my laptop, and there is a utility running called Extcap. In this case, an NRF sniffer by Nordic Semiconductor, which connects to this utility and interacts with it. And how this is all done will be the course of this presentation over the next few minutes. So the main motivation behind Extcap was that you have a utility which is capturing packets, which is capturing information that looks like packets, but it's not necessarily has a native interface to your system. I'm coming from industrial automation backgrounds. Most of the time, we don't have the capability of attaching sniffer devices to our networks, because then we will change the way the machine operates, so we might have interfered with that. And trust me, there is nanosecond reasoning behind why we can't attach tap devices. So if we don't are able to come to the packets, Wireshark has to kind of interface with whatever utility we have available. Now, for unknown reasons, pcap became one of the industry de facto standards for capturing data. It's really kind of funny to find utilities out in the field which have no correlation to networking whatsoever, but still use pcap as a capture format. Because in its core, pcap, all it does represent is a bunch of data in a packet kind of style attached on the top of each other. Wireshark in the past had one methodology of accessing data that's just pcap. So what you did in the past is you used pipes. This goes for Linux and Unix users, because as is the case, pipes is something Windows, by definition, is not very comfortable with. They do know how to do it. There is a concept there that works. But getting it to work in a utility or in a certain kind of mechanism that you can use to implement your own tools is challenging, to say the least. But to understand a little bit about how capturing with pipes or Extcap is working, we have to first understand a little bit about how Wireshark captures it all. Wireshark uses a utility called dumpcap, and all capturing in Wireshark goes through dumpcap. This has one main reason, and this is the super user capability needed for most capturing devices. In the past, we didn't use that, so you had to, in some scenarios, start Wireshark with super user rights to get a capture information packets from the network at all. And dumpcap uses pcap, or more recently pcap-ng, as the data format to communicate all the captured information back to Wireshark. You can actually run dumpcap on any machine. It's a standalone utility. It can use it to capture to pipes. It can use it to capture to files. It can, for instance, be a replacement for TCP dump. which it actually kind of is. And it works like that, that as long as you have a pipe open, it captures everything that comes along on that pipe, and closing the pipe is out of capture. Now, this is kind of the operating procedure we do it. Wireshark asks for the interfaces. We list all the interfaces. We start pipes with main Wireshark for the data exchange and read the captured data. This is kind of neat. The thing is, this is the code that gets it working on Windows, on Linux. So you need about 3 lines of code sorry, to capture on a remote device. This is how to capture all traffic with not including SSH from a remote device. The not including SSH part here is simply for not capturing the data we're sending back to our host machine. But this is how you do a remote capture with Wireshark. This is working out of the box, by the way. The same code for Windows, there is in our Wireshark wiki, there is a page detailing what you should do to with Windows, that it works as well. And with Windows, we mean without PowerShell. There are easier ways to do it with PowerShell. But with Windows, you're going to need about, I think, about 250 lines of code. So it's a little bit more complicated. The thing is, it's not very user-friendly. I mean, we're all super hackers. We all know about 1,000 commands out of the top of our hand, and we are proud ourselves of writing those commands. Just a show of hands, how many guys here, or ladies as well, deleted these hard drives by entering a command too fast and not reading it back? Who destroyed his machine at least once? See? It's a rite of passage. We have to do it. And this is what can go wrong. You can have a restart, start, stop issue. You cannot restart a pipe. The pipe runs. If you issue a command, it runs until I kill the command. You have broken pipes, broken writes. Some machines you're not allowed to open pipes. Some machines, the super user of the machine has denied you access to the pipe interface. And this is also what can go wrong. You're on Windows. This is, by definition, a problem in itself, but in this case, it also hinders you to work with those pipes. And if you restart, if you reconfigure your interface, this automatically means you have to restart, and in really bad cases, or most often the case, also Wireshark. So in the middle of a session tracing from a remote machine, you need to change the filter of dump cap, TCP dump, whatever. You have to stop the capture, reconfigure, start it again. This takes about 5-6 minutes, and exactly in that time, the machine goes down. And that was what you would like to capture in the beginning. So those are the usage scenarios we generally face. So we have data residing on different network environments. That's why we use pipes at all. Data not being networked here at all. Bluetooth is not a network protocol. Bluetooth, by its definition, is a wireless protocol, which means it has some network-like features in it, but by definition, we are not applying to the OSI layer model. System events, system logs. We have utilities capturing process monitor information on Linux, sorry, or even on Android devices. You can log on to your Android device and list the system calls, Bluetooth messages from an Android device. And RF environments. Now, I'm having fun at home. This is a small little Raspberry Pi setup, costs about 20 bucks if you buy it together on Amazon. It has a 433 megahertz receiver and transmitter. One of the neat things with 433 megahertz is that we use it everywhere. We use it in garage openers, we use it on our automatic blinds to close them and open them up again. But they're also used in respirators and, neatly enough, in fire alarms, light control system, home automation. It's widely used all over the world, has no encryption, and transmits all its capability freely open to everybody. It's fun sitting at 1 o'clock in the evening at home and turning on your neighbor's fire alarm. I mean, you have to test that your software is working, right? So to interface with all those and to overcome all those problems, there was a utility created by two guys called Mike Ryan and Mike Kershaw. It's called Extcap. That's short for External Capture Interface. They created it in the initial beginning for Kismet and other devices like that to be able to get the information back into Wireshark and be able to pre-configure those pipes and have a more user-friendly interface. It has been part since Wireshark 2.0, and its basic mission statement is to utilize the pipe management system and make a nice GUI for it. That's the main motivation behind Extcap. We want to have a GUI for the pipe interface. It has a few features. You can start, stop, restart. That's easy enough. You can handle interface configuration. I'll show you then later. And you have also runtime control. This Bluetooth sniffer that's running here provides to the user a nice little interface toolbar, which lists all advertising devices. And as you see, this information is changing. And I could go now and say, okay, somebody is called Max Bass, for instance, and go in and, no, let's take a little more active device because, and now all the information I see is specific to that device. This is something the Extcap pipe interface just got as a command and reconfigured itself, and now it just captures on that device. I can go back and capture on all devices. I can do, and the pass keys, I can, the advertising hub can be configured. Or, for instance, I can also look at log files the capture utility captures back to me. Now, all of those things are not, are not possible by using simple pipe interface, or not easily possible. Extcap does that by providing a certain kind of predefined interface on the command line for executables. So you create an executable, and the nice thing, as you can see here, is you can even create scripting executables. So it can be a Python script, it can be a Bash script. I tried it once with a basic script, just for the fun of killing myself with it. Yeah, you're completely open to which script language you want to use, but you also can have a C interface for it, write a C executable for it. And the way it works is the same way we had the steps before. So first of all, we're going to list all the interfaces this utility is providing, and then we make the configuration for it. So we can ask the interface, hey, now I want to know which configuration is happening on, let's say, the first interface you provided. And you get a nice GUI for it. With this GUI, I'm not dying, by the way, I'm just having a cough for the better part of 3 weeks. With this GUI, you have variants of options. You have the usual text, integer, you can have IP addresses in there, you can have times, multi-checks, radio functionality, you can provide files if you want to, passwords. Be aware that passwords are not stored securely, they're stored in plain text in a configuration file somewhere, so don't let them stored. You can even store this whole configuration, you can implement checks for ranges, you have mandatory fields, and you can provide help page links to your utility, so it can link to a website you provide where you explain all the possible interface options. We even have a reload functionality. Now this is something, there are sitting 2 guys in the audience from Antop who specifically wanted that feature. With Wireshark 3.0 we're going to have reload capability, which is actually kind of neat if you're capturing on a remote device, but you not yet know which interfaces it provides. So you have an initial interface configuration, which then has, after some kind of configuration, has the reload, and you say load interfaces, and this is actually what's happening. We ask the Extcap interface again, with all the already filled out configuration, hey, do we have any interfaces for me I can capture from? And in this case, we just updated the list, and it uses the new list as a configuration. And with Wireshark 3.0, we're introducing grouping so that the big dialog you saw in the beginning is becoming nice and simple. So you're having default option in this case, and you have 2, 3, 4, 5 sections, as many as you want. This is all done by a scripting language. It's simple text-based code, and you can implement it quite easily. As I've shown you, you can also create toolbars for it with buttons, selectors, all that type of stuff, and do it. Now, I want to show you in a second how to write your own capture utility. I'm going to live edit now here a Python utility we use. It will be a Python 3 driven example. It implements some configuration options. But before I do that, there is one example already available. All the screenshots I've shown you are screenshots from the main Extcap utility in the doc folder. So we have one Extcap example we provide by delivering with the program that's called Extcap example. And it just resides in the Extcap path we provide here. This is a screenshot actually from my laptop. It will differ if you have Windows, Linux, whatsoever, but it still can be found there. Now, the one thing I have to mention, because Windows, again, is a little bit different. You can't directly execute shell scripts. You have to create a bash wrapper for it. But still, you can do it as well, and there's an example in the header in there. Now, let's take a look at how an Extcap capture actually looks like, how such a file looks like. Let's see if we can get that zoomed. Oh. No? Well, then let's take my word for it. So, this is just a small, I took the major example and I hacked it all together. I will provide with this course, we'll add additional information to a website that I send out to the mailing list, where I put this example together with a Lua dissector, which then makes the dissection in Wireshark possible on a GitHub page and be able to download and play around with it. So, as I talked before, we have a few default settings. We have the Extcap settings. They're intentionally called Extcap something, so you don't mix them with your own settings. In my case, I have then a message option where I can provide an additional information to my Extcap utility. In the case of this example, it's only the possibility to provide a small message string and get information about this message string back. The rest of the code underneath is just basic Python code for parsing an interface. It doesn't really matter. You can copy it, just copy and paste it. The one important thing is you will find there for the message a little bit of code which checks if the message has some sanity to it, if it's the right message, if there's some things behind it that we need to check. In this case, if it's text at all or just zero length. Yeah. The real magic happens above that routine. So those are the 3 routines we use for creating a Python package for Wireshark. As I said before, Wireshark uses pcap as a capture format. Now, pcap sounds by definition very complicated to use and implement on yourself. The only thing actually you need to do is you need to get this header structure right. This header structure, as it stands here, creates a pcap message header. This is pcap, not pcap-ng. So you have some magic code. This is actually the magic code that has to stand at the beginning of every pcap file. Then I put in some pcap major and minor version. I set the time zone and the accuracy of the timestamps and the max length of the capture frames. Those values are all fixed and they're at the top of pretty much every pcap file out there. The one important thing I said here is the user type. Yesterday, for those of you who have been at the developer talk, you heard about something that's called DLT, data link layer type. Wireshark, when it captures information, has to distinguish somehow, what to do with this captured information. Most of the capture will be Ethernet if you plug in a cable, but not all of it. And Wireshark, by definition, doesn't figure it out. It gets told. So in this case, we tell Wireshark, this is going to be user type 0. Now, the guys who created pcap also created the DLT system somewhat. And they decided that there will be some certain user types used for your own applications, for your own test utilities, which don't reflect with anything else on the network. What Wireshark does when he sees one of those user types, he just presents the data. He does nothing to it. There is no dissection routine going on whatsoever. So in this case, we're going to use user type 0. One, by the way, would be Ethernet. And if you search for this, there is a small section in Wireshark source code. I just show it here to you. It's called wtap.h. That's a header file for wiretap, which is our library for creating. Those are all the user types that exist today. So you see we have one for Ethernet. We still have one for token rings, lib, PPP. Those are all old school protocols. But down there, user type 20 is IEEE 802.11. Isn't it kind of neat that from Ethernet to here, we just had about 15 codes, 15 to 20 codes. Those are 25 years of networking history, by the way. And you pretty much see what took off afterwards. Because those are all the codes that came beyond that. So you see we have some fiber channel here, some network analyzers use their own user codes, backnet codes, PPP over Ether. Here we have Bluetooth, LE, Bluetooth, Linux monitoring, logcat codes. So pretty much you can look at this and figure out is there a code already available which I can use. What will happen when I use Ethernet, for example, is that automatically Wireshark will start up the Ethernet dissector and pull all your packet information into the Ethernet dissector and lets it dissect. So if I have a utility which, by definition, just reads Ethernet frames over the network, I use, instead of 45 in my utility, I use 1 and automatically see all the information I have in Wireshark. If I have Bluetooth, I do the same. I have PPP, I do the same. So there's really very little information I have to provide in the Extcap utility in the sense of what this actually is. So coming back to it, I create a header, and then I create a package. Now the package is even easier, because in my case, each package has a small little header in front of it. That's the timestamp, the captured length, and the real captured length. Now there's a little bit difference of that. We all know Ethernet has about 1,500 bytes, but there are capture devices out there. You don't capture all of those 1,500 bytes for various reasons. For instance, if you're doing industrial automation, most of the time you're not interested in the data itself, but in the deterministic of the frames. So all you need to do is really capture the first 90 bytes or so, which will give you all the information you need for further analysis. So this will differ because we will say length in frame will be, for instance, 1,500, but length captured will be 90. And Wireshark knows this is the difference between when you see in the frame header, number of bytes captured, number of bytes in frame. This is pretty much where this comes from. This is actually also the thing, this is the frame header. When you see in a packet detail list, you see the list of packets. At the top, it always says frame number X, frame number Y. This is actually this information that's being represented there. So frame usually is the very, very first packet dissector we call. And then I'm being very lazy and just attach my message and doing nothing else. My message in this case is construed here. This is actually my routine. It's a permanently running thread which says, okay, I open a buffer Wireshark has provided me. This is the pipe. I send out the pcap header so Wireshark knows which type he is expecting and which dissection engine he should start. And then I just, on a continuous loop, send out the same information. In my case, I create the length of the message and print the message underneath it. So this is all to it. I've created a utility here and can put it out there. I mean, if you want to do your own utility, all you take is this exact source code and change those 3 lines. This is everything you need to do. In my case, currently, actually you just need to change this line if you want to. In my case, currently, I'm reading this information over a serial interface from this Raspberry Pi Zero. and dumping just all information from the serial interface out into Wireshark. I've used it quite for a few bits, not only the 433 megahertz, but also I'm doing a lot of home automation. You know, I'm being an adult male with a balcony and way too much budget. So I'm growing tomatoes, but it's way too easy to really tomatoes. The red things, not the things you say I'm growing green plants. No, no, real tomatoes. But it's way too easy to go out there and put water in them and look after them. No, that's no fun. So I have a fully automated watering plant system, completely overkill, but hey, gotta have your toys. And a few weeks back, I had the problem that I had two pots side by side, and the one was filled to the brim with the water. Interestingly enough, the plant didn't mind. And the other one was drying out. And I tried to figure out that problem, and usually I'm coming from an industrial automation company. What we do is fire up the hardware debugger. I was talking to you yesterday on the bus. Firing it, that's the go-to response every hardware guy has. Let's fire up the 3,000 euro hardware debugger and try to figure out where the signal goes wrong. I did a little bit differently, dumped it on a serial interface, put it on in Wireshark, and tried to figure out what's going on, and had the issue in about 5 seconds. So Wireshark basically acted as my data logger for my tomatoes. I even created a small little protocol dissector. I'll show you in a second. In my case, it was called tomato log. So I had all those tomato log packages. If you ever see a package dissector called tomato log, I got way too much time on that. So that's basically what you can do. In my case, those are not Ethernet frames at all. This is runtime information. This is traffic information. But the cheap thing about it is, now if I have a Wi-Fi integration into my plant system, I can easily correlate issues with the Wi-Fi to issues in the control of the automation system, of the irrigation system. Now think bigger. You have, for instance, you have an AC control system. An AC control system overheating for whatever reason. And you want to figure out what's going on. Nowadays, most modern systems have a data interface which can dump data on the network. But they can also dump data in log files. Wouldn't it be great if you had a log file or a Wireshark trace where you see at the same time the control messages sent to the AC system and the information the AC system did with it, time correlated. So I see, okay, this network message led to this AC shutting down, for instance. This is what you can do with those utilities, because Extcap, as every interface in Wireshark, is being capable of being merged together with other captures. I can capture on an Extcap and simultaneously I can capture on a Wi-Fi network link. And Wireshark will merge those two captures together and present them as one display. Now, Python is rather easy. This test Python, by the way, which I showed you a minute earlier, of course it works. If I find it here. This is what it actually does. Every second it generates a message. And I have a small Lua script running, which I can show in a second. But for now, you see every second it produces a message that's called 004 test, 4 being the length. I started writing this at the beginning of the keynote, and I finished 5 minutes later. So it's a real easy interface to use if you need some data logging. Yeah. Of course you can. Of course you can do the same thing with a C-based Extcap. Now, with C-based utilities, you have to work a little bit different. First of all, you have to compile them, and second of all, you have to have a lot of management stuff going on. In our case, we provided 2 utilities two header files and correlating source code called Extcap base and SSH base. Extcap base provides all the list interfaces, list configuration, DLT stuff, versioning information. And SSH base handles SSH connections. Now, with those two utilities, we have created now, I think it's 5 delivered Extcaps. I'm not really, yeah, it's 5. Called Cisco dump, SSH dump, Android dump, Rentbank dump, and what was the 5th one? UDP dump, right. Those utilities you tend to see appearing at the bottom of your capture list. Here, in my case, I have only allowed 2, UDP dump and Rentbank dump. Now, those have their own configuration interface, so you can hit here and you come to a configuration interface where you can connect, in this case, to a UDP server, which then comes exported PDUs, I think it is. What was the capture format that's going to be transported over the network? Exported PDU, yeah. And a payload data type, and it just dumps it on the system, and then can you look at it? It's written by Dario, that's why I'm asking him. If he doesn't know it, then who will? SSH dump does the same thing I showed you earlier with those 3 lines of bash script code. So it uses SSH, libpcap to be precise, to connect to a remote machine and executes pretty much any command that will dump pcap to a serial interface or to a pipe interface and reads it back through the SSH connection. Cisco dump is a kind of variation for that. Most Cisco interface routers have a SSH possibility to connect to and then dump log information from the Cisco interface or capture on ports, capture on devices, capture on a spanning port, for instance. Rentbank dump is just something for us which generates a random amount of data defined in various interfaces. And Android dump is actually a neat little interface which allows you to dump Android syslog messages, Bluetooth connection history, yeah, a variety of things. There is one utility, it's not really maintained at the moment, it's called Linux dump, which does the same thing for a Linux box. And Dario took up the mantle to try to get somehow Procmon or Netmon. What's the Windows utility called? Yeah.
And you can convert them using, I don't recall the name of the utility, but you can convert it to netmon format. Then you can open it in Wireshark, but I'm trying to skip this stuff. That's what I'm trying to do.
So we're on the fly of getting the Windows network or process information also dumped to Wireshark in this regard. This is going to take some time because Microsoft, and yeah. But sorry, somebody from Microsoft here? No? Okay, good for me. Yes, the thing is, when we're looking at tools in this regard, I mean, we're looking at all kind of varieties in that regard. But what we need is we needed to dump some kind of trace format file in a byte. That's the important part. Otherwise, we won't get it running with Extcap. The thing we have now is a utility which dumps the wrong format, so that's actually the problem we're having. But yeah. I mean, it can be anything. For an Extcap idea we had in the past was to use a satellite program so that we connect to the remote machine, install a small satellite utility there, and then use that to monitor and dump back data. It just grows with the complexity of the task. That's all it does. So one last thing I want to show you. If it's working. What you also can do is, once you've done that, don't stop there. In my case, I mean, we got, for whatever reason, we got the first part wrong still, but we created a small little Lua script to dissect my Genius test protocol. And if you ever wanted to learn Lua, that's 140 lines of code with a lot of documentation. So I'm putting both of those, this test utility and the test Lua script, we're going to add a little bit to it, but by putting both of those on a GitHub page, we also have an extensive documentation about Extcap called readme.extcap, Genius naming convention, which we provide with the source code, which we also are currently in the process of transferring into the help. And a lot of companies have started to taking up on Extcap as a capture device interface. My own company, for instance, uses it for our own network analyzer. The guys from Antop use it quite openly to get various stuff done. Simone is looking at me funny now. But you have a USB dump, for instance. There's a USB bcap dump. You can dump from USB devices, the whole handshake management interface of USB devices. And I leave you with a thought. This is a short course because morning we can have a little bit time more networking. I leave you with a thought. Think of the next thing that just produces data, which you want to see in Wireshark for whatever reason, because it's easier to look at for starters. And write your own utility for it. You will thank us for it, because it's really, it takes about half an hour top, but it eases development quite a bit. Thank you. Any questions? Yes. You wanna have a mic?
If I have to integrate inside Wireshark events coming from the kernel, such as sysdig or eBPF are doing, do you suggest to use this approach, or do you think there are better alternatives, or I should invent something extra?
Better approach in the sense of Extcap, or yeah. In general, I think for every data that's not network-based, not libpcap-based to be more precise, Extcap seems to be the best approach yet. Because for everything else, we need additional libraries, additional utilities. With Extcap, you have two advantages. First of all, it's an external utility. You can deliver it with your own product if you want to. So it's a real possibility for proprietary deliverance. The second thing is you're not that forced down on our coding rules. So if you have a lot of old stuff in your company, a lot of legacy code, which you need for this utility, it's easier to create an Extcap with it than to create a Wireshark-based utility. Because when you add code to our repository, we try to apply our coding rules to it as much as possible, because, and this is the main reason behind it, coming in 10 years, you might not be around, but hopefully Wireshark is, and we have to maintain it. I know this is quite, not you specifically, Luca, but
When another thing that would be useful is that with Extcap you can use whatever language you want, because you are not necessarily part of Wireshark. So if your interface is based on Python, as Roland did, you can do it, but you can write your utility using Ruby or Java or whatever language you want. So you are not forced to the rules in the sense of the API, but neither in the sense of the language. So that would be useful.
yes. And also we give one promise: the CLI interface won't change within the major versions of Wireshark. So each version will be compatible for the first version delivered. This is actually we emphasize very strongly on, which we focus very strongly on, because otherwise we would have to support all those utilities, and this is not happening. We even have a version check in there, so we can tell you which version of Wireshark we are running, and you can change your interface commands to whatever needs to be set. So, for instance, the reload functionality will come with Wireshark 3.0, but you can now adapt your utility to it and check if you're running on Wireshark 3.0 and then deliver those interface functionalities or don't deliver it. The grouping interface is implemented in such a way that if we find the group interface but don't support it, we don't break. We just see all stuff underneath each other. And if we find it, then we make the tabs. Yeah. Yeah.
Can it support custom user-defined log messages that aren't in nice syslog format? They have whatever format they wanted to define, and sometimes we have to read that.
Yeah, that's what we actually do with the syslog format. So there is no predefined computer-readable version of syslog. Syslog, by definition, is just text-based and whatever the user has configured. And the Android dump takes the syslog as it is defined by Google in the Android operating system and puts it into a computer-readable format. So as long as you can interpret the data and you know the schematics of it, you can create a utility from it. What one other company does is they read JSON data and transfer the JSON data into Wireshark packets.
So at first I thought that Extcap could only read the pcap and pcap-ng file format. Are you now saying that you can actually read any format that wiretap understands?
No, Extcap writes only pcap and pcap-ng. Extcap is applied to that format which dumpcap uses to talk to Wireshark. So we can write pcap, pcap-ng to dumpcap, but we can read whatever we want. We can read a meter reading if we want to. From Extcap, you can only read pcap or pcap-ng. One guy who isn't here yet, Paul Offred, actually implemented pcap-ng because he's using custom blocks. So with the trace, he's providing information on which interface the trace has occurred on. So when he has multi-capture from two interfaces, you can per packet decide, okay, this came from this capture, this came from that port. And so you can correlate timing differences, for instance, how much delay a certain device had between two ports and stuff like that. Any other questions?
Can you tell me more about the Microsoft ETL future? What's going on with the process monitoring or other SysTool internals, whatever?
Well, at the moment, we're trying to figure out how this format actually looks like. But Dario can tell you more about that.
So I'm basically working on two topics. The first one is to understand the format itself. And I couldn't find any specifications around, so I'm letting this down. The other one is to use native API, Windows native API, to read the files and to process the events with the goal of extracting the actual payload of the packets and to use libpcap that is within Wireshark to generate the output that the Extcap need. So I'm at the very beginning. I've just started. And I've found some examples around, but the documentation isn't very good. So basically, that's the path I'm trying to go through. If anyone knows how to do that and want to be in contact with me, I will appreciate that.
Have you measured the latency through the system if you're trying to coordinate like real-time Wi-Fi, but you're getting log messages from something else? I'm expecting the log messages through this would be delayed by some amount of time.
Well, the latency depends very much on the code you're using, and obviously you're getting a smaller latency. If you're using C-based code, then you would use scripting code. But in theory, it really depends on the style of programming you implemented. I measured it actually for my tomatoes, and it's about 150 milliseconds because of the Python interpretation and stuff like that. So I have an offset of about 150 milliseconds. Yeah. Yeah. But in theory, that's, I mean, you have to be sure that, or you have to somehow synchronize at the top the two traces, and once you've done that and have calculated the initial offset for the ongoing dissection, most of the time the offset stays deterministic and stays the same. Any more questions? No? Then have a nice conference day.